Good evening, students. Everyone, good evening. Can you hear me? Am I clearly audible, everyone? Good evening, Abid. Good evening, Johnson, everyone. How is the preparation going? Right, Sneha, Fars, Farhan, Adi, all of you. Good evening, everyone. Am I clearly audible? So, welcome back to the session on physics. Now, today we are going to see questions on alternating currents and current electricity. Alternating currents and current electricity. Okay, right. All right. So, in the first part, I'll be doing questions from alternating currents, and in the second part, Rafi sir will join you with questions in current electricity. Okay? And as I promised in the beginning, these questions are carefully selected. We have spent, our teachers, our expert teachers have spent too much of time. They have invested too much of time on selecting the questions, because we have taken this with an intention of helping you, and this is definitely going to help you in the examinations. Okay? So, the papers are set in such a way that it covers the whole chapter. It is all done in a sequential order as well. So, if you have learned the theory or if you have learned the equations, this is not going to be difficult for you. And all these questions are previous questions or similar to previous questions. Many questions have come as numericals as well. So, make sure that you practice these questions after the session. So, shall we start now? Everyone say yes, please. Yeah, happy leap day. Thank you, Abid. Everyone. Yes. Okay. Thank you very much. So, let us straight away get to the paper. Now, I am starting off with question number 1. Read question number 1 here. The voltage of an AC supply with the time varies with the time as V is equal to 120 sine 100 pi t cos 100 pi t. Okay, so they have given you the voltage equation. What is the value of voltage? Voltage is given as 120 sine 100 pi t into cos 100 pi t. Now they have given you the equation for voltage. V is equal to 120 sine 100 pi t cos 100 pi t. And they are asking for maximum voltage and frequency. Okay, that's a simple one. You might have done this already. You know what is a general form of alternating current? General form of alternating current is V is equal to V0 sine omega t. Or some teachers write this as E is equal to E0 sine omega t. V is called instantaneous EMF or instantaneous voltage, the voltage at a particular instant. Okay, V0 is called maximum voltage and omega is called angular frequency. Okay, this is called the general form of alternating current. So, first of all, we have to check if this is in general form. Now, is it in general form? No, never. Because we have something that is not needed. It has a sine function as well as a cos function. So, tell me what you're going to do. We have to convert the sine cos into sine ln. How do we do that? Now, you have to go back to the basics. In trigonometry, you learn this. Where do I write? I write it here. Okay. In trigonometry, you write this. 2 sine theta cos theta may be written as sine 2 theta. So I'm relying on my skills in mathematics. This is 2 sine theta cos theta, which can be written as sine 2 theta. Even for non-mathematics students, this won't be difficult because you have seen this many times in class 11. 2 sine theta cos theta is sine 2 theta. So I'm trying to get this into this form. How do I do that? Look at this. See what I'm doing. I'm writing this 120 as 60 into 2. 120 is written as 60 into 2 into sine of 100 pi t into cos of 100 pi t. Look at this. Now it looks like what? This looks like 2 sine theta cos theta. 2 sine theta cos theta. See this again. First of all, the given equation is not in general form. General form is only V0 sine omega t. Only sine function should be there. But in the given question, they have given you sine as well as cos. So how do you get this to sine form? You write this 120 as 60 into 2. Now this looks like 2 sine theta cos theta. Now look at this red circle, or look at this red line. Oh, sorry. Look at this red line. Now see this red line. Now that is in place of what? That is in place of theta. Now here it is sine theta cos theta. Here it is sine 100 pi t cos 100 pi t. So how are you going to write it now? Look at this. That is equal to 60 into 2 sine theta cos theta can be written as sine of 2 theta. Sine of 2 theta. Theta is what? Theta is what? Look at the red circle. Look at the red circle. Look at the red bracket. It is 100 pi t. So see what I've done. 60. 60 is as such. Then 2 sine theta cos theta is what? Come on, tell me. This is sine 2 theta. Sine 2 into 100 pi t. What is this now? That is 60 into sine of, tell me, 2 into 100 pi t. That is 200 pi t. Now it is in my general form. Look at that. I can write this next to this. V is equal to 60 sine 200 pi t. Now you can easily compare and find the values. Now see this orange circle. In place of V0, I got 60. So I got V0 is equal to 60 volts. Now this V0 is called peak value or maximum value or amplitude of voltage. Peak value or maximum value or amplitude of voltage. And second thing is, look at this orange circle. What is in place of omega? It is 200 pi. Omega t is 200 pi t. So what is omega now? Omega is 200 pi. You know what omega is? Omega is 2 pi into frequency. If you remember, omega is 2 pi into frequency. What is omega now? 2 pi into frequency is 200 pi. Then pi and pi are cut. 2 and 2 are cut. Eventually you have frequency is equal to 100 hertz. So your final answer is maximum voltage 60 volts. Frequency is 100 hertz. Maximum voltage is 60 volts. Frequency is 100 hertz. Answer is option C. How many of you got the answer? Very good, Russell. Very good. Christopher, Muhammad, Rishabh, very good. All of you. Right. Yes. Thank you very much. All of you got this. Could you please tell me, anybody wants it again? Tell me, I'm asking you. Right. Everyone. Right. Okay. So, there may be other questions also. They might ask you to find RMS value. Now that you got V0, you can find RMS. How do you find RMS? RMS is written as this. RMS is V0 by root 2. So you can put that V0 value you got. What is V0 value? V0 value you got here 60, right? Put it back to this. It is 60 by root 2 in case they ask. Okay, that is another previous question. Now hope you got this. I am moving to the next slide now. Okay, so look at this question. An alternating voltage is represented as E is equal to 20 sine 300t. The average value of voltage over one cycle will be. This is so important. I would pick this as a very one of the most important questions from this topic. Look at this. This is an AC and this is called the positive half cycle. This is called what? Negative half cycle. Positive half cycle and negative half cycle. Positive half cycle and negative half cycle. And together they constitute full cycle. full cycle of AC. Okay, and over this half cycle, we have calculated the average value in class. What is average for this half cycle? It is given by 2 by pi times E0. What is average? You got a number of voltages here. Look at that. All these are voltages. Infinite voltages. Infinite voltages. Infinite number of voltages. You add them up and then average them. What are you going to get? That is going to be 2 by pi E0. What about this one? For the negative half cycle, the same average is minus 2 by pi E0 this time. Why minus? It is rightly called negative half cycle. Negative half cycle, right? So you got a positive half cycle, you got a negative half cycle. They are asking about over one cycle. One cycle. So what is the average over one cycle? Average over full cycle. Average over full cycle, if you are finding, that's going to be plus 2 by pi E0, that is for the positive part, and plus minus 2 by pi E0, that is for the negative part. So these are getting cut. Finally you get what? 0. So average over the full cycle is 0. Now you can learn this as a standard question. Average value of AC over a complete cycle is 0. Average value of AC over a complete cycle is 0. Average value over a complete cycle, full cycle, is equal to average value of current over a full cycle. It is equal to 0. Average value of AC over a full cycle is 0. Hope you got this. All of you understood this? Everyone. Can you tell me? All of you. Can you just comment? Yup. Right. So we will move to the next one now. Now see this question. An inductive circuit contains a resistance of 10 ohm. So resistance is given 10 ohm. Inductive circuit means what? And an inductance of 2 Henry. So basically it is an inductive circuit. Inductive circuit means an inductor. But a resistor is also there, contains a resistor. So it is actually an LR circuit. LR circuit. Okay. So look at that. They say an inductive circuit. That means already an inductor is there. Then there is a resistance. They won't probably say resistance. They will say a bulb sometimes. Bulb means what? Bulb is a resistor always. Bulb has a filament. Filament has a resistance. So tell me what? This is an LR circuit and an inductance of 2 Henry. Okay, so this is the circuit I'm looking at. Okay. And the voltage is also given 120 volts. Frequency is given 60 hertz. Then the current in the circuit would be. What is the equation for current? You have to trust Ohm's law for everything, right? You see that so many times. Current is given by voltage by. No. You won't call it resistance this time. We will call it impedance. Impedance. What is impedance? This is nothing but Ohm's law. Ohm's law says what? Current is equal to voltage divided by resistance. Current is equal to voltage divided by resistance. But here the name is different. Only the name is different. Okay. It is called impedance of the circuit. Impedance is what? Total resistance of inductor and resistor. Total resistance of inductor and resistor. I'll write them here. Look at that. R is given in the question. What is the resistance? Is that given? Yes, 10 ohm. Resistance is given 10 ohm. Then for inductor, the resistance is called inductive reactance. Inductive reactance, which is XL. XL, yes, XL. XL is the inductive reactance, L omega. L omega. So let us put the value. Inductive reactance. This is resistance of the resistor. This is resistance of the inductor. Inductor. Alright. It is L omega. Let us put the value. L is what? 2 Henry. L is given in the question 2 Henry. Omega is what? 2 pi into F. Omega is 2 pi into F. Omega is 2 pi into F. Okay. Do not worry much about it. I am going to approximate as always. Right. You might say I am being overconfident here, but trust me, it is MCQ, so you can go with approximation, no problem. All right. So pi value is what? 3. I'm not taking 3.14. Forgive me for that. Right. This is 3. 3 into 2, 6. 6 into 2, 12. 12 into 6, 72. So that's going to give you 720 ohms. Okay. So let us put it over here. Right. What is this? V divided by, what is the equation for impedance? Root of R square plus XL square. Original equation is root of R square plus XL minus XC the whole square. Correct? For an LCR circuit. But is it an LCR circuit? No, 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 no. It doesn't have a capacitor, right? It doesn't have a capacitor, right? It doesn't have a capacitor. So it is basically an LR circuit. So you just need to consider L component and R component only. So let us put the values. Tell me what you're going to get. This is voltage. How much is the voltage? Do they give it? Yes, 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 120. So 120 upon root of, this is 720 square. 720 square. Plus, oh no, look at this. This part is 10 square. Resistance is 10. 10 square plus 720 square. Now, are you planning to calculate this? Never ever do that. Because compare 10 with 720. Compare 10 with 720. That is nothing. Yes. Compare an ant with an elephant. Is an ant having a size in comparison with elephant? This is like an elephant, right? 720 square is somewhere like 49 into 4 zeros, 4,90,000. Whereas this is only 100. 10 square is only 100. This is like 5 lakh or something. So I better skip it. I just cut it. Tell me what I'm getting. So that is, I'm writing it here, okay? 120 divided by, now that I lost this 10 square, it is root of 720 square. Root of 720 square. Root of 720 square. I forget about 10. Okay, it is as if I haven't seen that 10 at all. Right. So root of 720 square is 720. Root of 720 square is 720. 0, 0 cut. 12 by 72 is 1 by 6. 1 by 6 is what? Roughly 0.16. Is there such an option? Oh, yes. Yes, spot on. We got the right answer, jackpot. Got it, all of you, everyone? Oh, it's lagging. I'll ask the technical team. Right, Mohammed. It is still lagging, right? Okay. So can we just break it for a second? Hello guys, we are back. Can you hear me? Am I audible? Can you see me? Can you hear me? Can you please reply in the comment box? Hello guys. Hello. Nope. It seems we are down, right? Could someone please tell me? Am I audible? No. Can you hear me? Hope you can hear me now. Yeah, I can see your responses. Yes, we are back. Right. Okay, so hope you're okay with this question. Shall we move to the next question now? Shall we move to the next question now? Right. Thank you, Devika, Farhan, Sneha, Rishabh, Johnson, Christopher, Gabby, Sneha, all of you, Muhammad. Okay, so moving to the next one now. Next question now. Read this. In an LCR circuit, the voltage across each of the components LCR is 50 volts. LCR circuit voltage across LC combination will be. Okay, so I take an LCR circuit here. This is inductor. Then I have a capacitor and a resistor to which I am applying an AC voltage. This is called an LCR circuit. Okay. So I have an LCR circuit here, inductor, capacitor, resistor. They are all parts of the circuit. Okay. Now they say what? The voltages across each of the components is 50. So this is what? Okay, this is across inductor. I'll just draw this. Across inductor, the voltage is 50. Across capacitor also, the voltage is 50. Even across the resistor, the voltage is 50. Okay? So they say what? Voltages across each of the components is 50. So you will understand one thing. If you look at this, voltage across inductor is equal to voltage across capacitor. Look at this. Voltage across inductor is how much? Voltage across inductor is 50. Voltage across capacitor is 50. So I can say voltage across inductor is equal to voltage across capacitor. This condition is called resonance. Resonance in LCR circuit. This happens when you give a frequency called 1 by 2 pi root of LC. Okay, so when you feed this particular frequency, to the LCR circuit, voltage across inductor and voltage across capacitor will be the same. And this condition is called resonance in LCR circuit. Resonance. Okay, I'll tell you more about resonance now. But anyway, they are asking you to find voltage across LC combination. LC combination means you are connecting a voltage. Hello guys, we are back and we are really sorry for what happened, and it was not intentional. Can you hear me now? Am I audible? Everyone say yes please. Everyone. Yes. Yeah, thank you everyone. Thanks everyone. All right, so let's not waste time now. This is what it is. Voltage across LC combination is the question, right? So how do you find it? Voltage across inductor is 50. Voltage across capacitor is 50. That means both the voltages are same. What does it mean? Voltages are same means the circuit is at resonance. Circuit is at a condition called resonance. Resonance. At resonance, what is the voltage? I told you VL and VC are the voltages, right? And this time you are finding voltage across LC combination. LC combination means one end is connected to inductor, next end is connected to capacitor. So you are finding voltage across LC combination. I can call it VLC. What is VLC? VL minus VC. You may have a tendency to take it as VL plus VC. Never fall in it. Never fall in the trap. It is VL minus VC. Right. Why? Because voltages in inductor and capacitor are out of phase. Out of phase. We learned that in phasor diagram. If you remember, phasor diagram, this is how you draw VL. Upward, VC, downward. So the value will be VL minus VC. Never ever do it. Never ever add them up. So what are you going to get now? 50 minus 50, that will give you 0. So here the answer is, option D. Option D is answer. Understood this? All of you got it? Everyone. This is done with an intention. I told you, we have spent so much of time on setting the papers. So this is all carefully done for you. Okay, so make sure that you follow this properly, please. Okay, it's a humble request. Okay, so I'll tell you a few more things about resonance which might be of help to you. This is something you learn in classes. I'll tell you about resonance. At resonance, there are many things you can say. Number one, inductive reactance and capacitive reactance are equal. XL will be equal to XC. And at this point of time, just give me a second. I'll maybe write. Yeah. Can you see me now properly? Right. XL is equal to XC. XL is equal to XC. Can you see me now? Okay. Right. Number two, circuit Z, impedance of the circuit will be resistance. Why? Because it was root of R square plus XL minus XC the whole square. Impedance, right? But XL and XC are equal. Look at that. What is that getting you? Right. These are getting cut. Tell me what you get. Root of R square. What does it mean? It means that Z is equal to R. Z is equal to R. Now at this point of time, you can say circuit is purely resistive. That means even though inductive and capacity components are there, they are not playing anymore, right? They are not showing up anymore, right? Only the resistive component is acting now. Okay, so purely resistive. Circuit is purely resistive means voltage and current are in phase. In phase. In a resonant circuit, in a resistive circuit, voltage and current are in phase. So what will be phase difference now? Phase difference will be 0. Phase difference between voltage and current is 0. Only at resonance. It can be anything between 0 and 90. But only at resonance, phase difference will be 0. Now, 6th point, in that case, power factor. There is something called power factor, which is cos phi. Which is cos phi is what? Cos 0 is equal to 1. That means at resonance, power factor of LCR circuit is, it's a previous question. Power factor of LCR circuit at resonance is cos phi is equal to, come on, cos 0, which is equal to 1. I'm not done yet. 7th point. These are all taken from previous board questions. Okay. 7th point. You know, I said impedances are only now, which means impedance is minimum. Impedance is minimum. Impedance is minimum now. That particular condition is called resonance. Okay. Now, if impedance is minimum, current is maximum. Current is maximum. Because when resistance is minimum, maximum current can flow. Resistance is minimum, maximum current can flow. 9th point, I said XL is equal to XC in the beginning, right? If I multiply both sides with IXL becomes equal to IXC. What is this guy? This guy is called voltage across inductor. Current into resistance is voltage, right? So VL is equal to current into resistance is VC, right? Voltage across inductor becomes equal to voltage across capacitor. That is what we used here. Voltage across inductor is equal to voltage across capacitor. Voltage across inductor is equal to voltage across capacitor. And 10th point, V will be equal to VR. That means applied voltage. Applied voltage, how do you write it? Where do I write it? Okay, so V, the applied voltage is, this is the equation, VR square plus VL minus VC the whole square. Hope you remember this. Hope you remember this. Your teacher must have taught you. VL and VC are equal. VL and VC are equal. Equal means that part gets cut. So you get V is equal to root of VR square. V is equal to VR now. I forgot to write one thing. Power is also maximum. I am writing it as 8A. Power is maximum. When current is maximum, power is also maximum. Now these are my inferences at resonance. Okay, so when resonance happens, all these things would happen. You can take a screenshot if you want. First is what? Inductive reactance becomes equal to capacitive reactance. Then Z is equal to R. That means impedance now becomes resistance only. Circuit is purely resistive now. Voltage and current are in phase now, because for a purely resistive circuit, voltage and current are in phase. You learned this. Then phase difference will be 0, and phase difference is 0 means power factor cos phi will be cos 0, which is 1. Again, impedance is minimum because it was Z is equal to root of R square plus something. Now that something is gone, right? So it is, impedance is minimum, current is maximum, then power is maximum. Then I told you VL is equal to VC and applied voltage is equal to VR. Hope you got this. All of you understood this. Everyone, please say yes so that we can move faster to the next slide. Okay, all of you got this. Everyone, Sanush, Abid, Sneha, yes, Johnson, Adi, all of you, Hibba, Christopher, Farhan. Okay, so from the slide you're definitely going to get one question. Trust me on that, you know. So I'm giving you my word on this. This slide will definitely give you one question. Minimum 1 mark, maybe up to 2 marks. Okay, 100% sure. All right. I'm not saying 99.99, 100% sure. Question number 10. So the next question. In an AC circuit, voltage and current are given by V is equal to 100 sine 100t. Look at this. Voltage is given. How much is the voltage? Voltage is given 100 sine 100t. So in an AC circuit, voltage is given 100 sine 100t and current is given. How much is current? Current is, what is it? 100 sine 100t plus pi by 3. Remember, it is milliampere. This is volt. Okay. And what do they ask here? They are asking you to calculate the power dissipated in the circuit. Again, an important question. Power dissipated. Do you remember the equation for power dissipated? Power dissipated is given by E0 by root 2, otherwise called ERMS. RMS value into I0 by root 2. Your teacher might have taken Vm by root 2. Different teachers use different notations. Okay, so I thought of using E0. It's fine, no problem. E0 by root 2, I0 by root 2 into cos phi. This is what? This cos phi is the same cos phi we used in the previous question. Do you remember? There is something called power factor, I told you, cos phi. So that cos phi is how much? That is called power factor. So let us put the values now. Tell me what is E0? E0 is what? E0 is the very first number you see here. The first number the number you see immediately after equal to. Okay. After equal to, what you see is 100. That is called E0. So 100 upon root 2 into, what is I0? I0 is the first number you see in the equation for current, because basically this is V is equal to V0 sine omega t. This is current is equal to I0 sine omega t plus pi by 3. Okay, so I0 is how much? 100 by root 2 into cos of, what is the phase difference? Look at the phase angle, 100t. Look at the phase angle for this guy, 100d plus 5 by 3. So what is the phase difference? One is 100t, the other is 100t plus pi by 3. So what is the difference? What is extra here? Can someone please tell me? Extra there is what? Can someone please tell me? First one is having a bracket 100t. Second one is having 100t plus pi by 3. Yes, pi by 3. Thanks for that. Thanks for that, Abid, Christopher, Abid, everyone. Right, Hiba. Alright, so I can put that pi by 3 over here. It is cos pi by 3. Now, what is it getting to? 100 into 100. Oh, I know. You know, I forgot to put that milliampere thing. 10 raised to minus 3. It is milliampere, right? So, milli I have to convert to amperes, right? So, milli means what? 10 power minus 3. Tell me, 10 power minus 3. Right, 10 power minus 3 amperes. Now, tell me what you're going to get. So, let us cut 0, 0, 0 with the 10 raised to minus 3. What will we have now? 1 by, oh, there is a 10. 10 by, root 2 into root 2 is 2. Cos pi by 3 is called cos 60. Cos 60 is 1 by 2. What am I getting now? This is 10 divided by 2 into 2 is 4. So the answer is 2.5 watts. So answer is C, 2.5 watts. All of you got it? So again a frequently asked question. Make it quick please. Okay, so we are moving on. Right, moving to the next question. See the question now? The potential difference and current flowing in an instrument in an AC circuit are given by V is equal to 5 cos omega t and I is equal to 2 sin omega t. The moment you see the question, you have the answer. Ask me why. Ask me why. Ask me why. Because, why? Nobody is asking why. Because, yes, thank you. Right, because one is a sine function, the other is a cos function. Sine and cos always differ by pi by 2. Sine and cos have a phase difference of pi by 2. Okay, so anyway, I'll tell you. So when you take cos pi by 2, power will be what? 0. It is a frequently asked question again. You know, they will give you one sine function, they will give you another cos function. Then you have to find the power. The question is power dissipated. Power dissipated. So Power dissipated is given by what? Again the equation. Power dissipated is given by E0 by root 2, I0 by root 2 into cos of phi. Okay, what is EMF? What is EMF? EMF is given 5 cos omega t. EMF is given 5 cos omega t. 5 cos omega t, EMF. Current, where is current? Where is current? Where is current? This is 2 sin omega t. Come on guys, I is equal to 2 sin omega t. Now look at this. One is a sine function, the other is a cos function. How do you convert between them? Sin 90 minus theta, cos theta. Sin 90 plus theta is also cos theta. You learned that in class 10, trigonometry. Okay, don't say that you haven't seen it, because I'm sure you learned that in class 10. Sine and cos always have a phase difference of pi by 2. So I'm putting it straight away here. I don't mind what this is. Okay, anyway, this is cos of pi by 2, right? Cos pi by 2 is what? 0. So the power dissipated is 0. Answer is option A. All of you got it? Tell me everyone, tell me everyone. Okay, right. Nothing Rishabh. You know, one is sine function, the other is cos function. Current is sine function, voltage is cos function. So they will have a phase difference of pi by 2. Phase difference of pi by 2. Sine and cos have a phase difference of pi by 2. So power, when you calculate, this will become cos pi by 2. That is equal to 0. So one is sine function, the other is cos function. Phase difference is pi by 2. Power will be 0. Hope you got it. I'm moving to the next one now. Now read the question. This is so many times asked in examinations. All right. You know, read it. It's asked as a, what do you call a long answer question. Read it. A bulb and a capacitor are connected in series to a source of alternating current. Frequency is increased while keeping the voltage constant. Then, what is this? A capacitor is there and a bulb. I have told you already, whenever you see a bulb, you must take it as a resistor. Why? Why? The bulb has a filament. The filament is a resistor. So it is implied that a resistor is there. Okay, so let me draw that picture now. Let me draw that picture now. This is the capacitor and this is the resistor. Right. And you know, you may ask, where does that resistor come from? This is the resistor. If bulb is given, that is resistor. Capacitor is also given, right? They might even give inductor bulb question also. Same method. Okay. Now what is the question? Frequency is increased. I'll tell you. First of all, what is the equation for current? Current is given by V by Z. Current is given by V by Z. This is nothing but Ohm's law. Current is equal to voltage divided by impedance. Okay, it is so important. You check the previous papers to see if I'm lying. So, I is equal to V upon root of R square plus 1 by C omega the whole square. Or rather, I'll use the original form, R square plus XC square. R square plus XC square. Why don't I use XL? Because XL is not part of the circuit. Only XC is there. Now let us see. I'm going to do something here. They are saying about frequency increasing. Let us see what happens. You know, XC, frequency increases. What will happen to XC? When frequency increases, XC is given by 1 by C omega, which is 1 by C into 2 pi F. Okay, so when frequency increases, tell me, this is purely mathematical. Tell me, when frequency increases, denominator increases. Denominator increases means XC value will decrease. XC value will decrease. XC value will decrease. When XC value decreases, the square root will decrease. When square root decreases, where is the square root? Denominator. When denominator decreases, current will increase. Current will increase. That is our conclusion. The more the current, the more will be the flow. more will be the brightness. So the more the current, the more will be the brightness. The bulb will give more intense light. Yeah, that is the correct answer. Bulb will give more intense light. Okay, so I'll give that one more time. Okay, this is so important. Same question can come with a bulb and an inductor. Inductor, so then you have to put an inductor here. Then the question will be based on L omega, XL. Instead of V by root of R square plus XC square, you must be using what? Root of R square plus XL square. So let us see this question one more time. Current is given by what? V by Z. V by Z, that is V by root of R square plus XC square. V by root of R square plus XC square. Z is root of R square plus XC square. Then what do they say in the question? They say that the frequency increases. Frequency increases means XC is 1 by C omega, that is 1 by C into 2 pi f. When frequency increases, denominator increases, so XC will decrease. Where is XC? Where is XC? XC is on denominator. So denominator as such will decrease. When XC decreases, this denominator decreases, current will increase. More current will flow. When more current flows, you know what happens? When more current flows, the bulb will glow more brightly. Then they can have different variants of this question. They might say frequency decreases, then capacitance increases, capacitance decreases, resistance increases, or you introduce a slab inside the capacitor. When you introduce a slab, capacitance will increase, right? Oh no, tell me what? When you introduce a slab in a capacitor, capacitance value will increase. So if they say, what I was trying to say is, this question can be asked in different ways. Alright, they might say capacitance increases, capacitance decreases, then frequency increases, frequency decreases, or you're introducing a slab. Alright, many ways this question can come. Expect this question this year. Alright, it is so important. Shall we move to the next one now? Can you please tell me? If you respond, we can move on. We have more questions coming up, right? If you do these questions, you are sure to get questions, 100% sure. Trust me on that. Now, next question. An AC source of angular frequency omega is fed across a resistor R and a capacitor C in series. Okay, omega. I'll mark the important areas here, key points. Omega is the frequency. It is fed across what? Resistor and a capacitor. So it is basically an RC circuit. The current is I. If the frequency of source is changed to omega by 3. So first case is what? First case is omega, and resistance is R, capacitance is C, then current is I. Second case is what? They say frequency is changed to omega by 3. Maintaining the same voltage. Current is found to be halved. Current is found to be halved. So what happens to current? I by 2. Calculate the ratio of reactance to resistance at the original frequency. Calculate the ratio of reactance to resistance at the original frequency. Did you read the question? So I'll tell you the crux of the question. What they're trying to say is, at omega, the current is I. When omega changes to omega by 3, current will be I by 2. Current will be I by 2. Okay, so let us do this. I don't have space here, so I'm doing it. I have two cases. Keep this in mind. I'm using another board. Right, omega, current is I. Omega by 3, current is I by 2. So let us go to this. Right, so just give me a second. I'll just clear it. Okay, one second. Right, so I have two conditions which I'm going to do now. Right, so look at this. So first case I'm writing the equation for current. What is the equation for current? V divided by root of R square plus 1 by C omega the whole square. Okay, why do I write this way? Because in case number 1, can you see this? Omega is the angular frequency, I is the current. So look at that. Omega is the angular frequency, I is the current. In second case, omega by 3, I by 2. Omega by 3, I by 2. Say it again, omega by 3, I by 2. So let us go back to that, omega by 3. So I am writing second current as I by 2, that is equal to V. Voltage does not change. They have given that in the question, divided by root of R square plus 1 by C omega by 3, the whole square. Okay, 1 by C omega by 3 the whole square. Okay, or I'll do that part on the margin, that's better. That will be less confusing for you. Alright, so I am writing, first case I am writing XC square itself. Okay, so XC is how much? 1 by C omega. XC dash, second case, how much? 1 by C omega by 3. See, in case number 1 it was 1 by C omega, right? Case number 2 it is 1 by C omega by 3. Let this 3 go to numerator. So XC dash will be 3 into, this 3 will go to numerator. 3 into 1 by C omega. What is this guy? Tell me, it is actually old XC, right? So you get new XC as 3 times old XC. Look at that. It is new XC is what? New impedance is 3 times the old impedance. So you can put them over here. Tell me what you're going to get. This is like 3 times XC the whole square. So XC dash is 3 times XC the whole square. Now just divide them. This is equation number 1. This is equation number 2. You're going to find a relation between XC and R. Tell me how you're going to do it. I'm going to divide 1 by 2. Look at that, look at that. I'm going to be real quick on this. 1 by 2. Tell me. Equation number 1 by equation number 2. What is it? What is it? Come on. I by 2. I by 2. I and I are cut. 2 goes to numerator. That is 2. Correct. So that will be 2 on the left side. And when you take the ratio, this guy gets cut with this guy. So 1 by this root by 1 by this root. Take the reciprocal. Root of R square plus 3XC the whole square divided by root of R square plus XC square. Finally we can square and cross multiply. Square it. This is 4. 2 square is 4. And cross multiply also. R square plus XC square is equal to, take the square on right side. R square, oh no, this 2 is not there, okay? My bad, right. So it is R square plus 9XC square. Okay, so tell me what you're going to get. This is 4R square plus 4XC square is equal to R square plus 9XC square. Now tell me what? Get identical terms on one side. 9XC square, 4XC square goes to the right side. 9XC square minus 4XC square. 9XC square minus 4XC square. That will be 5XC square is equal to 4R square minus R square. That will be 3R square. What is the question? I don't remember. Calculate the ratio of reactance to resistance. Reactance to resistance. Now let us get back to this. Reactance to resistance. What is reactance? XC. What is resistance? R. So get this on the left side. XC square by R square is equal to, forgive me for this, I don't have space here. Now 5 goes to right side. 3 by 5. So take the square root. You get root 3 by 5. What is it? Root 3 by 5. Is that there in the options? Yes, option A, root 3 by 5. All of you got it? Everyone, could you please say that in the comment box? Could you please say that in the comment box, everyone? All of you got it? Everyone. Come on guys, tell me please, tell me. Right, nothing, you got 2 conditions. At omega, current is I. At omega by 3, current is I by 2. So you are writing 2 equations. At omega, you are writing the first condition. At omega by 3, you are writing the second condition. Then you divide them, cross multiply, square, then simplify. In between, I have done something. What is XC? 1 by C omega. 1 by C omega. right? So in second case, XC dash will be 1 by C into omega by 3. Why omega by 3? They say that it is not my contribution, it is coming from the question, omega by 3. Let us get that 3 straight away to numerator. What is it now? It is 3 times XC. So new XC is 3 times old XC. So let us go to the next one now. Maybe I can do a couple more questions, okay? Now this is a direct question. Quality factor of LCR circuit. I intentionally did this because it has come many times. Quality factor of an LCR circuit. Q factor is given by, we have two equations in reader, L omega by R and 1 by C omega R. Alright, and now it is not specifically mentioned in syllabus, but still you could expect this question, okay? Because quality factor has a third equation, 1 by R into root of L by C. That is another question. What is quality factor in the first place? A resonance circuit has two applications. First one, metal detectors. When you go to the airports, when you are being frisked, you are asked to walk through a gate. Have you seen that? Have you seen that? You walk through a gate, and if you carry something in hand with a metal, that will be sensed. Correct. It is called a metal detector. Metal detector, the working principle is resonance, electrical resonance. It's a resonance circuit. Okay. It's very difficult to detect gold. Okay. So next time if you are traveling, if you want to carry a gun, do carry a gun with gold, made with gold. Okay. Right. So that is actually resonance circuit, application of resonance circuit. Okay. One application. Second one, tuner circuit in a radio. You know, in our times, you know, like 20 years back, we used to have this particular kind of radio, analog radio. Nowadays, you have everything on the mobile phone, right? Digital radio. Right. We used to have analog radio in the past, where we tune a station. And that radio or a tuner circuit is also working on what? Selector circuit, a tuner circuit. What is it? It is resonant circuit, LCR series circuit. Now for it, we have something called quality factor, which is a unitless quantity. Quality factor is a unitless quantity. It is L omega by R or 1 by C omega R or 1 by R into root of L by C. In the past, how did they ask questions? You know, they would give you R value, they would give you L value, they would give C value. You just have to substitute and find out quality factor. Got it? But in this question, they are simply asking for quality factor equation, which is option A, L omega by R. All of you got it? Maybe I can try a couple of more questions. Everyone. Right. Yes, there we go. Right, I was just joking, okay. It's not on record, right? I hope. Right. Okay. Right. So, look at this. Next question. This is again an important one. It's a direct one. It's a factual information based question. All right. You can learn it by heart. Answer is 2 omega. Answer is 2 omega. Answer is 2 omega. It is so important. I'll repeat. The alternating EMF of angular frequency omega. EMF's frequency is omega. Why? EMF is written as E0 sine omega t. E0 sine omega t. Current is written as I0 sine omega t. So EMF's frequency is omega. Current's frequency is omega. We can mathematically prove that power has a frequency twice omega. Power has a frequency twice omega. That's a standard question. Same question comes in similar in first year topic also. You don't have to prove it. Okay. It is mathematical again, purely mathematical. You have to use trigonometry. Alright, anyway, you can learn by heart. An alternating EMF of angular frequency omega is applied across an inductance. The instantaneous power developed has an angular frequency. So, angular frequency of power is 2 times omega. Say it again. Angular frequency of power is 2 times omega. Angular frequency of power is 2 times the frequency of voltage, frequency of current. So here the answer is direct, option D, 2 times omega. Mark it, you will see this year. It's so important. Hope you got it. Okay, 2 times omega. 2 times omega. Alright, 2 times omega. Yes. Now this is again a direct question. Right, question number, okay, next question. An alternating voltage is equal to 200 sine 100t is applied to a series combination of R. Resistance is given 30. Inductance is given 400. Since we lost 10 minutes in between, we might extend by 10 minutes, okay? Right. So 30 ohms and inductor of 400 millihenry. The power factor of the circuit is. Power factor is what? We have already done 3 questions on it. Power factor is given by R by Z. R by Z. That is equal to R by root of R square plus XL square. Why don't I write XC? Why don't I write XC? They are saying about only inductor. Look at that. Inductor only. Inductor, right? No capacitor. No capacitor. All right. No capacitor. Only inductor. So it is root of R square plus XL square. So I am putting the value that is equal to resistance value is there in the question 30 divided by root of 30 square plus XL I am finding on the margin. XL is L omega. XL is L omega. Right. L omega. What is L? It is over there. 400 into 10 raised to minus 3. Omega. Where is omega? You see sine omega t. Sine omega t. Sine omega t. This is sine omega t. So omega is 100. So cut zeros with the 10 raised to minus 3. You're getting what? You're getting 40 here. So this is 30 square plus 40 square. That is 30 divided by. You try this calculation yourself. 3 square 9. 4 square 16. That's going to make it 25. Root of 25. Root of 2500. That is 50. 0, 0 cut. 3 by 5 is 0.6. That is there in the options. 0.6. All of you got it? One last question. I'll wind up. I'll hand over the session to Rafi sir after this. Right. Okay. All of you got this? Yes. Moving to the last question. Question number. Yeah. Question number. Next question. Okay. In the circuit shown below, what will be the readings of voltmeter and ammeter? Okay. The moment you see this question, one thing is certain, that this is a resonance circuit. It is at resonance. How did I confirm that this is resonance? How did I confirm? Can you check this out? Can you check this out? Oh, I don't have it. Oh, I think I wiped it. So do you remember the 11 conditions I wrote at resonance? 11 conditions I wrote at resonance. What was the 10th condition? Do you remember the 10th condition? VL is equal to VC. There are 11 things happening at resonance. I told you. I took them over the past couple of years from different papers. Voltage across inductor is equal to voltage across capacitor. So look at this. What is voltage across inductor? Voltage across inductor. Look at the left end of inductor. It is connected to the voltmeter. Right end of inductor is connected to this voltmeter. So voltage across inductor is 300 volts. What is voltage across capacitor? Voltage across capacitor. Voltage across capacitor is also 300 volts. Do not worry, they'll be giving like that only. So what can you say? Voltage across inductor is equal to voltage across capacitor. So what do you conclude? Circuit is at resonance. Now in that case, remember the 11th condition. What was the 11th condition? What was the 11th condition? Applied voltage will be equal to voltage across the resistor. Applied voltage will be equal to voltage across resistor. Applied voltage will be equal to voltage across resistor. This voltage will be equal to the applied voltage. What is this voltage? That is this voltage 220. Applied voltage is given here, it is 220. Applied voltage is given here 220. That will be the voltage across resistor. Okay. So I can say voltage across resistor is 220. So voltmeter reading I got to find ammeter reading also. What is ammeter reading? Ammeter reading, current is V by Z. Current is V by Z. That is V by R. Why? Look at condition number 2. I wrote 11 conditions. Condition number 2 is Z is equal to R. Z is equal to R at resonance. So tell me guys, what is V here? 220 divided by, what is R here? R is given in the question, 100. So cut them out. You are getting 2.2 amps. So look at the voltage, 200. Look at the current, 2.2. Voltage is 200. 220, right? 220 and 2.2. So answer is option C. This is a very, very important question. And did you understand this? From the figure, it is clear that voltage across inductor and voltage across capacitor are equal. 300 across VL, 300 across capacitor. So VL is equal to VC. So circuit is at resonance. Circuit is at resonance. So you can say that the applied voltage is equal to voltage across resistor. So VR will be 220. And current, if you want to find, you have to use Ohm's law. Ohm's law. Ohm's law is I is equal to V by Z, or rather V by R. Z is not to be taken anymore. Only resistive component is active. So 220 by 100, that is 2.2. And if they ask the voltmeter reading here, that will be what? Across LC combination. I did this already. That will be 0. Why? Why? Because VL and VC are out of phase. This is 300, that is 300. They are out of phase. Out of phase means they would cancel out, right? That's going to be 0. Alright, so across this combination it is 0. There was a board question, when you add these algebraically, it will be greater than the applied voltage. How do you resolve this paradox? Go back and check it out. Okay, I'm giving like, say, 300 reals to first guy, 300 reals to second guy, and say 220 reals to third guy. Now, I gave only 220, but can that be like greater than this? 300 plus 300, 600, plus 220, 820. I gave only 220 reals, but they got 820 reals. That is not possible. Then how can you resolve it? That is called a paradox, some sort of a discrepancy. Paradox. You can't do that. Algebraic addition is not possible because these are out of phase. You have to instead take 300 minus 300. So that will cut 0. Now it's okay. The problem is solved. What you gave is 220. That will appear here as 220. Okay. So that's all from me for the time being. We lost like 15-20 minutes in between. That's what. Anyway, we will be coming back with more sessions. Now, Rafi sir will continue the session. He is coming back with current electricity. Please stay until the end because even the last question will matter. As I told you, all the teachers have spent so much of time on setting the papers. This is done with an intention, not like any other thing, because this is the last moment, so we know how precious the time is for you at this point of time. All right, so we have invested so much of time, even though we are all among busy schedules, we have invested so much of time in it. So particularly the current electricity topic is very important, and Rafi sir is going to make it very simple for you. You're going to get very important questions in board examinations also. So thanks for staying back. Thanks for all the patience. Now over to Rafi sir. Thank you very much. See you then.
Yes, hi everyone. Good evening all. Good evening all. Can I start the session? Yes, hope you guys are in the last moments of preparation for the board examinations. So we can continue our discussions. Hopefully you got a very important discussion from my colleague Lijo sir, AC chapter. I saw the last question which is really important in AC, that inductor resonance conditions which are usually repeating in AC chapter. Keep in your mind, you have to focus that pattern, okay? Value will not repeat, but the pattern will repeat. Concentrate on that question again, rewatch it, ensure you learn that question, okay? Which are very, very important. All right. So can we start then our discussion? Current, electricity. Am I visible, right? Am I visible? Am I visible to you? Can you comment on the chat box all? We can start. I will deeply discuss all the questions. Each questions will convey you a lot of information. Last moment helping material questions are arranged here, touching current electricity. Current electricity is one of the very important chapter. Again, it's a numerical oriented chapter. Okay. So you guys are here now. Yes, Devika. Yes, Adhinath, Christopher, Kalyan Alle. Yes, Kalyan Alle. Everyone is here. Yes, guys. Razal Bhai. Yes, all. Yes, Adhinath, Abid. Yes, Abid. Yeah. Abid level kind of questions I considered here, Abid. So let's focus on the discussion. I'm not wasting your time. Come back all. Keep the book and paper ready with you, and you can keep a juice bottle is also on side of your table, study table, and show this video, this moment to your mom also. Tell her to give some juice or something. Give to maintain your energy. Hello guys, please enjoy the moment which you are studying. Okay, these moments will not repeat. Okay, remember this moment will not repeat. So put your maximum effort. You will not study then after these few days after. You will not study for physics exam. There is no more physics exam for your life. So give a maximum effort. Let's learn this. Okay, let's learn. Every question here through the discussion, I will communicate to you some of the informations. Okay, regarding these questions. All right, all. Yes, you guys are really giving energy to me. Let me continue then. Come on, guys. Let's focus on this question. The first question related to drift velocity. Can we start? Yes. Come on, guys. We can start this. Read the question carefully. Drift velocity of you guys are read this now. Drift velocity of free electrons of conductor in a conductor is V. Drift velocity is given. V. When current is I, okay, actually the dot is here. Okay, the current is I, drift velocity is V. It is flowing. Okay, I is flowing. If both, this is a question start from here. If both the radius and current are doubled, then what will be the drift velocity? All right? Yes. So don't worry about it. Let me start this one. So through this question, I'm discussing theory also for you, for your convenience. So here, look at the case number 1. There are 2 cases mentioned in the story, right? In this question. Case number 1. What's case 1? Drift velocity is usually represented what? VD, drift velocity. Did I want to give a quick a communication of what is drift velocity? Yes, you guys are expecting so? Look here. I hope you guys have learned this. Drift velocity means what? Look at this. Imagine here a battery attached to a conductor. And what is inside present? Electron will be present. And you can see here what is here, the positive is attached. And here it is what? Negative. So the negative electron will attract it towards our positive. So as a result, you can see electron get accelerated. When electron get accelerated, will it go like a straight line? This is what you guys are thinking. Electron will go straight line, but answer is wrong. Electron will not go straight line. Okay, look at this. That concept I want to communicate to you. Focus on this. Electron, it is initially. What's the direction of initial motion of electron? If the battery is absent, think about that situation. Battery is absent, electrons are in random motion. When imagine battery absent, electrons are, it's going in the random motions. Let's see, the yellow one will be initial direction of electron. Now, when a cell is attached, electron experiencing a force to the left hand side. So see, something is going up. Suddenly it's experiencing a force from this side. As a result, what happened to the path of electron? Look at the path of electron. The path of electron get, curving towards the force. Something is going like this. Suddenly it got a hit from this side. Then what will happen? It will turn. Imagine a car is going like this. Sir, how car is going like this? Think. Then you can imagine like something like going to the sky. Okay, so then it's going like this. Suddenly it got a force from this side. Then how will it go? Will it go like straightly like this? No, sir. So it has a momentum initially like this. Because of this force makes it start curving down, right? So what happened to this electron? This electron will curving down. Okay, then what will happen? Will it continue the curve? No, sir. Here what is present? Atoms, ions, another thing which is present like in conductor. Maybe another electron. Due to that, what will happen? Collide and comes back. Collide and comes back. When it collide and comes back, again somebody is calling from this side electron. Again electron goes to this side, then again goes back because of the collision. So slowly, dhire, electron will be approaches toward the positive side. So actually that's one of the question. I am communicating you the path of electron inside a conductor when battery is connected. It is not a straight line. It is a parabola is the answer. You understood? That's one of the MCQ. What is the path of electron when a battery is attached? It is a parabola. Many guys will write straight line because they saw like in the 10th standard textbook and all, it's like electron going towards the positive. When you enter to the minute concept level, electron, curving down. So it's a parabolic path. So but overall, electron like hitting over here, comes back, hitting, it's dhire, slowly, it's come towards here. So what is overall? Overall, electron is, drifting towards this side, drifting the right side. That velocity is called, how fastly the electron is approaching to the positive side. That velocity is called what? Drift velocity. How will you define drift velocity? It is the average velocity gained by the electron when a battery is attached. Or little more, you can make a like a scientific definition. It is average velocity gained by the electron when electric field is applied. Cell applied means what? Electric field is applied. That's what drift velocity. All right, you got the basic, right? Now come back to this question. So here, drift velocity of electron is initially V. What's the current initially? Sir, current is I, no change. Now what story is telling here? Case 2, look at this, something they are changing, right? Case 2, something they are changing. What's change they are mentioning here? If underline this word, if both radius and current are doubled, then what will be the drift velocity? So drift velocity is how much in the new case? Okay, new drift velocity. What happened here? Current is doubling, and what will be the drift velocity? Radius also doubling. So see here, I can say here current relation and drift velocity. Here current and drift velocity, how it is connected? That's what the key concept. You know that current and drift velocity, everyone please look here, I is equal to NEAVD. NEAVD is the formula for current and drift velocity relation. If you forget about the relation, I will teach you a Malayalam to the Hindi, all English wala atmi. Now look here, there's a Mallu word famous is there. I is equal to NEAVD, you know, to remember NEAVD, right? It's in a Malayalam language, and it's like the meaning word tu kidhar hai. Okay, where are you now? So remember that coding, okay? I is equal to NEAVD. Don't forget it. I is equal to NEAVD. That's the relationship between current and drift velocity. Keep in your mind. Okay, so you learned that Malayalam, right? Come on, I is equal to NEAVD. This is the formula. This is the first case. I is equal to NEAVD. Now, what this case is telling? Look at this, I is equal to NEAVD. So here, from here, drift velocity can be written as I by NEA. I by NEA. Because current is I, drift velocity is VD. So it's the first formula. Now come back this case, VD dash, new drift velocity. What are things, what's the current become here? Did you read that? Current is doubled. So I become what? 2I. I become 2I. What is another thing? Is it N changed? N means what? Number density. How many electrons are present in 1 meter cube? In unit volume, how many number of electrons are present? That's what we called N, number density of electron. E means charge of electron. A means what? Area. So these two are not changing. That's a material property. Number density, it's not depends on what? The volume, etc. Is it the water density depends on how much water is present? No, right? When area doubled, something is doubled, then dimension doubled, no matter about the number density. Okay, so electron charge is also not matter. But what happened to area? Can you say what happened to area? Is it area is doubled? Is area is doubled? No. What is doubling here? Radius doubled. Marabai, what is the radius of a wire? What's the radius of a wire? Area of a wire, pi r square. So when radius double, how area and radius they are proportional to r square. Many guys will make wrong here. See, when radius double, area become 4 times. Area become 4 times. Why? Because r square, na? Look at this, r square. When r become 2, when r become 2 times, then r square means what? 2r the whole square, which means 4 times. Okay, 4 times. So here area become 4 times. Now, you know, let's compare these two equations. Just to compare these two equations. Equation number 2. Yeah, let me tell you that. See, so I-N-E, look at this, okay? Look at this. What that? Oh, some new shape. No, I-N-E-A. What is that? This one, right? Drift velocity. So may I substitute this as the, yeah. What else are present here? Look at this. This all part I call it as V. Because drift velocity, what's given in the question? Drift velocity, initial drift velocity is V. So this is V. So this part is V. Then 2V by what is left here? 4 is the denominator. So if you solve this, V by 2 is the answer. Okay? V by 2 is the answer. You got a good information, right? When I solve this question, you got it? So new drift velocity become V by 2. So students making mistake area here, one is, you know, they will take area doubled. No, area not doubled. When radius doubled, area become 4 times. Area become 4 times. When radius tripled, area become 9 times because area proportional to r square. Hopefully you got this information. Can I move from this question? You got it, na? Yes or no? Clear. Yes sir. Great. Oh, Alan Shijo. Oh, mera bhai, Pipi Shijo, you're here. Yes. Oh, great. David Drovin, yes. Okay, got it now. Really hot questions we are discussing. Really hot questions. Yes. Come on, let's explore the next level of question. Okay, I'll again communicate to you proper content through these questions. Focus on this area. So little bit tricky level because I know you guys are prepared some manner. So I'm discussing little above so that you can solve the all under questions. Read this question carefully. Okay? The variation of potential difference versus current graph is given. Like VI graph is given. And what is there? What else is given? Look at the data. Let me underline that. Length of the wire is 31.4 centimeter. And diameter of the wire is a diameter, okay? Understand that. So if you are getting a question paper and all, in order to avoid the mistake, you guys can do like whatever I am doing, okay? Underline the values. And if it is a diameter, underline. Our mind will decode like sometimes it's a radius, so you will get wrong answer. Okay, so underline, that's very important, okay? One tough technique, you can avoid the careless mistake happen. Now, the resistivity is measured as, look at the resistivity is given, x into 10 raised to minus 3 ohm centimeter. And then what's the value of x? That's the question. Dear all, one thing you can notice here, should we need to convert centimeter to meter here? No sir, because resistivity final value is given in what? Centimeter. So you don't want to convert the centimeter and all. Okay, so here we can find that x. Can you think how to find this? What this graph? VI graph. So from this VI graph, you guys know that resistance, how will you find? Sir, slope of VI graph. Okay, so easy question only. After learning this, you will understand the concept, okay? Resistance equal to slope. How will you find, children, slope of a graph? We have a simple equation, tan theta is there. What is tan theta? Theta is basic. What is theta? Theta is the angle made by the straight line with x-axis. How much it is here? 45 degree. Okay, when angle given, how will you find the slope? Tan theta. What is tan 45? How much? 1, right? Tan 45 is a good number. So resistance is how much? 1 ohm. We got from the graph. Hello, sometimes this entire question may not repeat. But you guys, if you see this kind of thing, maybe this part may repeat in your board examinations. Such a quality questions we are doing. You might not be needed the entire part. Sometime, they cut and ask like some parts. Okay, so last moment, really helping content to you. So please focus well. So resistance is 1 ohm. That's fine, right? Now, what we need to find? Resistivity. Okay, because resistivity is given x into some unknown. So we have to find resistivity. Then we will equate that resistivity value this. How will you find the resistivity? Yeah, do you know? I will tell a shortcut to you for finding the resistivity. All my kids, wherever you are sitting, you guys can remember resistivity is the name of me. Like, you know, rho is equal to Rafisar by L. Look at this. Rho is equal to RA by L. Don't forget about that, okay? Rho is equal to RA by L. Remember the formula? You can, if in case if you're getting forget about this one, you can use for a few days this trick, okay? Come on. What's the resistance value? 1, sir. What's the area? How will you find area of a wire? So side area of a wire. See this one. Side area. What side area, macho? What side area? Come on. It's circle, right? Wire cross section. Wire cross section. What it look like? Circle. How will you find area of a circle? Wherever I focus, area of a circle will be, sir, pi r square. Or what's another one in terms of diameter? Pi d square by 4. If diameter is given, pi d square by 4. Because diameter will be twice the radius. If you substitute that, you will get its pi r square again. Okay, so that's the area of a circle formula. Here diameter given. So let's find the area. Area will pi value how much? 3.14. What's the diameter? Diameter square. What's the diameter? 2.4. Should I want to convert into centimeter? No. Centimeter to meter? No, right? Why? Because resistivity is given in ohm centimeter. Remember this kind of careful observation. You don't want to waste your time by unwanted substitutions. Okay. So resistivity will be, a diameter will be that thing by pi d square by 4, right? That's what area. Then what's the length? What's the length? Length is given 31.4. Length is given 31.4. So this is what resistivity, but this value is given as what? X into 10 raised to minus 3. Then you can find here X, right? You can find here X. Lot of informations are there. Hopefully you got this. Now the numbers are really easy numbers only. Numbers are really easy. Look at this 31. Such a number only they will give is a 10, right? 10, 3.1s are 31.4. Understood, right? Now if you solve again, yeah, come on. This become what? 2.4, the all square means what? 2.4 into 2.4 divided by, what is left in denominator? 4 into 10. Okay, I can bring that 10 raised to minus 10 to down. Is multiplication goes to this side become division. Then division, 10 raised to minus 3 come down. So when 10 raised to minus 3 I pick it up, then what happened? 10 raised to plus 3. So 10 raised to plus 3 in numerator. Where from that comes? I took it from here. Once again, my students, all of you please focus. 10 raised to minus 3 multiplication here. Bring it this side become division. So it's actually 10 raised to minus 3 is below. When you take it up, it becomes 10 raised to plus 3. Understood, right? Now you can give the 10 to these values. 2.4, 2.4. If you give 2 tens, then it's become 24 into 24, right? Okay, and you can cancel this 10. So what it left then? 24 into 24 upon 4 is equal to X. Now you know the cancellation, right? Come on, do the cancellation all of you. So this 4 and 24 get cancelled, 6. So X become 24 into 6. How much is 24 into 6? 24 into 6 if you solve, you will get how much? 24 into 6. Make it fast. 24 into 6. 144, right? Students got the answer. Great. Oh, Kalyan alle. Correct, na? Correct. Sneha Suresh. Good, Sneha Suresh. Yes, there we go. Johnson, Hiba. Correct. Great. You know, you got getting the information, right? Please note down the information. Anything you feel tricky or something extra point you are getting, please note it, okay? Area of a wire, a side area of a wire will be if radius given pi r square, diameter given pi d square by 4. Clear, na? Pakki baat. Clear, na? Can I move to the next question then? Good. When a VI graph, how will you find resistance? Slope. Slope, how will you find? Tan theta. Okay. If angle is given, tan theta. That way. Let me move to the next question then. Focus on the next question. Touching the all concepts, okay? Very quickly. Look at the next question, all of you. A current 5 ampere. Read it. A current 5 ampere passes through a copper conductor. Resistivity is given. Current is given. Radius of the cross section is given. Find the mobility. Hello, new word? Yes, mobility of the charges if their drift velocity is given. Sir, what do you mean by mobility? In case you forgot, I will repeat that for you. Current electricity topic. That means if you are not completed the current electricity chapter, through this question also you can in such a deep way I am discussing this one to you. You know guys, what do you mean by mobility? Sir, mobility is basically the magnitude of drift velocity upon electric field. So how will you define mobility in examination, school examination when they ask, board examination when they ask? It is the ratio of drift velocity of electron to the electric field. It's the ratio of drift velocity of electron to the electric field. This is the mobility formula. Okay, clear now? So just remember, that's only the mobility part you needed, like a 1 or 2 mark questions, like numerical, mostly it's numerical. When they ask like 1 mark definition, how will you write it? It is a ratio of drift velocity to the electric field. All right, now that is the mobility. That is the mobility formula. Mobility formula. Now see. Question asking what is the mobility, right? Come on. So question is asking what is the mobility. What's the mobility formula? Let me write here. Mobility is equal to drift velocity upon electric field. Now look at this. All datas are here. Check it. Drift velocity is ready. Oh, that we can substitute here. Then electric field is ready. No, electric field is not ready. Sometimes you may get direct question, electric field also. They will give, then you can find it the ratio easily. Come on, how to find the electric field? It requires little more equations. Concepts. Come on. What is given? You guys can write what are the given data here. Given that in the board examination, if sometimes you are not getting, I telling this all average kids also, like in case if you are not getting the final answer, if you the step has mark, so remember while you are presenting the answers and all, at least write what are the given data, something you have to write. Okay. Rather than leaving that questions. Okay, so you have to do something. Sometimes the question may be incorrect. If you are lucky, then their teacher they will provide the extra mark to you, those students who attempted. Okay, so that means don't avoid that chance. That only you will get it when you are attempting something. Okay, like given that something you write, then you will get the mark. Okay, so sometimes that might happen, especially in physics and all, due to the typing mistake and all. Maybe one value got error, then answer will not get. Now such questions may be deleted later. So you will get that mark. Okay, come on. Given that is happening. So I don't know you are lucky or not this time. Okay. So a current is 5 ampere. A current is 5 ampere. Come on, let's write 5 ampere. What we are waiting here, we need to get the electric field. We need to get the electric field. Come on. Current is 5 ampere. Resistivity is given. Resistivity. What's the resistivity? Rho, right? 1.7 into 10 to the power minus 8. It is an ohm meter. Radius of the cross section is given. Radius how much? 5 millimeter. How will you convert millimeter to meter? 10 raised to minus 3 meter. Millimeter, how will you convert? 10 raised to minus 3 meter. Yeah, drift velocity is ready. So we have to find electric field, right? From this data, how to find electric field? Oh, how to find electric field from this data? Come on, let me tell you the formula to you. Look at this electric field. We can find what are things we have now. I is there, area we can find, right? Radius is available. What else we have? Resistivity we have. We have resistivity also. These 3 things we have. We have to find electric field. How to find electric field? You know one thing, vector form of Ohm's law. Anyone remember? Can you comment vector form of Ohm's law? Can you comment vector form of Ohm's law? Yeah, no, Devika, your batch is not unlucky. No, you guys are good. Okay, you guys are good. Yes, you will get great blessings this time. Don't worry. Okay, you will get like easy questions only. But you want to work hard. Okay. So J is equal to what? Sigma times E, right? This is a vector form of Ohm's law. J is equal to sigma times E. Current density into yes, Sneha Suresh. Sneha Suresh is a good girl, no? Oh, great. J is equal to sigma E. What is sigma called? Sigma called conductivity, right? Sigma called what? Conductivity. What do you mean by conductivity? Reciprocal of resistivity is called conductivity. All right. Now, what is J? Current density, right? Is recalling it. We take the equations. Current density is what? Current per unit area. Okay, equal to, this can be written as what? 1 by rho. Let me make in terms of the letters which we have. Okay, so you can find E from this equation, right? I is ready. A you can find. And sigma, it's rho, right? Sigma is 1 by rho. So you can find E. How to find E? Tell me how to find E. I by A into rho. I by rho you should bring to this side. So E you can find by I by A into rho. So once you find the IE, then you can substitute for the mobility. Okay, so come on, how to find this one? I by A. What is I value? Let me take the value from here. I value is how much? I value is 5 ampere. I value is 5 ampere. So you have to find first of all E. I will be 5. Then what is the resistivity value? 1.7 into 10 raised to minus 8. Okay, resistivity value how much? 1.7 into 10 raised to minus 8 divided by area. Area, how will you find area? Area is, area, radius, radius is given. So it's like a straight wire, cylindrical wire, area pi r square, right? Pi r square. So area will be pi r square. What's pi r square? 3.14 into, what is the radius, Manavai? What's the radius? Radius is 5 into 10 raised to minus 3. So 5 into 10 raised to minus 3, the all square. You guys try this. So you will get what? Electric field. Look at these numbers are easy numbers. They are giving again to you. Like you can cancel 3.14 and 1.7. You want to create an experience. Okay. 2 into 3.1, 2 into 1.7 is what? 3.14, right? Yeah. Now let's do this, all of you. Try the calculation. Let me do that part here. Hopefully you got this. Let me do the value of E calculation. 5 into 10 raised, you guys can try, okay? 5 into 10 raised to minus 8 upon, what's the denominator left? 2 is left here. 5 if you square, it become what? 25, sir. 10 raised to minus 3 if you square, how much? 10 raised to minus 6, sir. Then, the 5 and 25. Or, you have better idea. 2 into 25 is how much? 50. So, 5 by 50 is how much? 1 by 10. 2 into 25, 50. 5 by 50 is how much? 1 by 10. So 10 raised to minus 6 and minus 8 and minus 6 get cancelled. 10 raised to minus 2. So when this 10 also goes up, it become what? 10 raised to minus 3. So electric field we got. What's the unit of electric field? Newton per coulomb. So you got electric field. Now you can substitute for the mobility, drift velocity by electric field. Okay, don't worry. You can work this question. Then you will get lot of information. Develop your analyze skill. Okay, so E value you got. So what's the drift velocity? 1.1 into 10 raised to minus 3. Drift velocity is 1.1 into 10 raised to minus 3. What's the electric field value you got? 10 raised to minus 3. 10 raised to minus 3. You can cancel that. You will get what? 1.1. So mobility will be 1.1. 1.1. What will be the unit of mobility? It can be asked. Velocity, drift velocity meter per second is in Newton per coulomb. Okay, so the unit comes to be, tell me unit, meter per second upon Newton per coulomb, right? So the coulomb goes up, then coulomb, meter, and Newton and second goes up, no? So Newton raised second raised to minus 1. So this is the unit of drift velocity, mobility. Drift velocity meter per second. Electric field unit is force by charge, F by Q. So Newton per coulomb. So the coulomb goes up, so coulomb meter. Second goes down, so Newton second. So this one is the unit, okay? That is the one unit. So what's the answer? 1.1. 1.1 is the mobility of the electron. I think 1.1 is not there in the option. So it's closest to 1 is the answer, okay? Closer 1. So the answer is exactly 1.1. So but answer is little more closer, answer will be 1.11. Okay, 1.1 is close to 1, not 1.3. Okay, it has little more extra, no? So but you guys don't want to worry about it. It's not like a competitive examinations, like for you time being the value, if you are approximately writing like or 1.1 you're writing, you will get the mark. Okay, in case of MCQ options, 1.1 the answer will be what? 1. Okay, option is only 1 available, then use that one, not 1.3. 1.1 to 1, 1.1 to 1.3, which is close. 1 is close, right? So you can select that option. Okay, leave it. So hopefully you got a lot of information I conveyed here. Maybe any part of this can be asked like to you. What's the drift to mobility formula? You guys learned, no? Mobility formula. Tell me the mobility formula. Mobility formula, sir. Drift velocity by electric field. But we made little bit confusion about how to find electric field, right? So electric field we can find by using this many ideas. Okay, this many ideas. So write in a paper and repeatedly focus. Then you also get this kind of ideas to do the questions. Are you getting now? Pakka? Yes. Let me go to the next question then. All right now? All right. Everybody okay with this? Use the chat box again. Use the chat box again. You lose your energy. No, right? Come on guys. Yes, Johnson, Joseph. Yes, Ananya, James. All right, all. Yes. Great. And it is a leddu question, okay? It's a leddu question to you. You all can take this leddu question. It's easy questions, relaxing question. You can relax now. Okay, easy questions. 10th standard level of question, but board expectable questions. Come on, I think my explanation is not needed for this. You can try this. It's easy. I hope someone will give the answer or already given the answer to me. Yes, Shakib. Oh, Shakibul Hassan. Yeah, Kalyan Alle. I know. You guys will answer this one. Yes, Adinath. Great. David Rovin. By David J. So option A is the right answer. But anyway, we need to learn for this one like a theoretical examination how to do this, right? Come on, I want to teach you to the all kids here. The resistance of the wire is R ohm. If it melted, so case 1, before melting is my case 1. What is the length L? What's the area A? What is the resistivity rho? What's the resistance formula? Rho L by A. Okay, resistance formula rho L by A. So this is the case 1, before stretching. Before stretching. Then case 2, after stretching. Case 2 means how to do for the examination, theoretical examination like this. Case 2, after stretching. After stretching, what will happen? Yeah, length become n times. Imagine here you have a bada wire here. Dekho. Yes, what's the length of this one? L. What's the area of this one? A. You gonna stretch into n times. Then what will happen to this? Tell me, what will happen to this? Things become narrow, right? Look at this. Things become narrow. Imagine you are stretching a rubber band. Then what will happen? Is it the area remain same? No. Area become thin. What happened to area? The same time area become what? A by N. Which means what? If you double the length, area become half. That stretching is a special case, okay? Stretching is a special case. If the question is related to stretching, then length changing time, simultaneously area also changes. When length become NL, area become A by N. Understood? Will the resistivity change? No. Resistivity depends on the material. I told you, if I change the amount of water in a tank, will the density will change? Density of water change? No. Similarly, resistivity is the property of the material. Okay, it's not an amount, it's not based on the capacitance, like how much the capacity of the tank, etc. So if it is water have this much density. Wherever you put in like a glass or a tank, density remains same. Similarly, if you stretch a wire, compress a wire, resistivity will not change. It's independent of the geometry of the wire. It only depends on material which is manufactured as well as the temperature. Understood now? Yes, keep in your mind. That's also information, okay? Come on. Then what is the new value of resistance here? Come on. Will resistivity change? No, it's rho itself. What's the length here? Length is N times L. What about area here? A by N. When N goes up, N and N, the friends are meeting. N and N, N square. So then what is left here? N square times rho L by A. N square times rho L by A. So sorry guys, the student David Ruvin, Kalyan Alle, Shakibul Hassan, those who did this one, hello, just relax for a time because I want to teach the other kids also, okay? Oh yes, come on. Rho L by A. What is rho L by A? So rho L by A is initial resistance. Look at this. That's before stretching. What's the resistance? That's called rho L by A. So I can call this is N square times R. N square times R. So that's option. N square is an expectable board pattern, okay? Keep in your mind. So guys, if it comes like an MCQ questions like this, you can also use like a short formula for MCQ questions. If you stretch a wire into 3 times of its length, what will be the new resistance? 3 square into R, which is 9 times R. If you stretch into 4 times, then 4 square R, 16 times R. Likewise, you can use a shortcut for MCQ questions. If it comes MCQ, don't do this, okay? Don't do this. Just keep in your mind, it's a very standard and famous question. Of you guys are got these ideas, and if you are preparing for NEET and JEE, it's one of the fundamentals for NEET and JEE also, this shortcut, okay? I hope you guys are got. It's a special case. Remember, stretched wires. In future, any 10th standard kid, if they watch, it's also common topic to you also, okay? Later you can watch it. Expected, you guys are done this. Let me move to the next question. That question is easy, now come back to your level. Come on. Are you here? A fire is not coming now. You guys are tired? I am also tired, yaar. I am started the revision in the morning. No, I'm not saying I'm tired. You guys are tired more than me. You guys are working really hard. Appreciated all the kids who are preparing for the board examinations. Really supporting to you. Yes, all. Yes, all. Yeah, come on guys. We can togetherly work hard. Hello, fire is there. Oh, great fire. Yes. Yeah, that's the energy. Come on, let's do the next question. Now let's do the next question. Yes, read this question carefully. You guys are trying this? Make it fast then. Fastly do. A conducting wire of length L, area of cross section is A, resistivity is rho, connected between the battery, at terminals of battery. A potential difference of the battery is what? Developed between the ends. It's causing an electric current. This is the first part of the story. Okay. If the length of the wire for a same material is not changing, which means resistivity remains same. What is doubling? Length of the wire is doubled and the area of cross section is halved. Then what will be the resultant current? Two situations are there now. Before the change, after the change. If this kind of question, something is changing time, before the change, after the change, you can do likewise. Okay, you can do likewise. Okay. Thank you. Yes, someone created my fans association also. Hey, yes. Leave it. Concentrate on the quality contents. Okay, qualitative content. Yes, all. Come on. A conducting wire of length L, area of cross section A, resistivity. So let me say the case one. A conducting wire of length L, area of cross section A, resistivity is rho, connected between the terminal potential difference, which is N, which is V. We developed what's the question asking? The resultant current. No? So we have to make what are the given data here? Length is L, area of cross section A, resistivity is rho, and potential difference is V. Yeah. So let's consider this moment. What is current? I. How these all are connected? Can you connect this one? Yes, sir. Very simple, no? This connection is very simple. Small idea only. I is equal to V by R. Small idea only. Just to develop. In case you are not getting this, you will get now. Okay? You will feel this easy. Come on, let's do. V by R can be written as rho L by A. You learned this one also. Chemistry also multiple times. Rho L by A. When A goes up, you will get what is I. I will be equal to VA divided by rho L. Okay, VA divided by, is it visible? Is it visible to you? VA by rho L. Let me call this equation number 1. Let me call that is equation number 1. Now, case 2. Look at the case 2 here. Case 2. What's the case 2 story? What happened to the length of the wire here? Sir, length of the wire is doubling. What's the length here? 2L. What is the area? Look at the area. Did you notice that? Area is halved, which means what? Area become, initially is A. Now it is what? A by 2. Now it is what? A by 2. Understood? Then same material, right? So which means what? Resistivity remains same. Okay, resistivity remains same. Then what is asking? What's the current at this case? You got the idea, right? How to find the current? It is connected again across the same battery. So V will be remain same. It is not changing, okay? The cell which is connected is not changing. So V again. So what will be the current in this case? How will you find? I is equal to V by R. What is R here? Rho. Resistivity is rho. Length is what? 2L. Area is how much? A by 2, right? Area is A by 2. Am I correct? Area is A by 2. If you do this, so this thing become V by rho into 2L. A by 2, how to do? A by 2, V by rho L is become 2 by A. Something I made wrong. Focus on this. A conducting length L, area of cross section A, resistivity is rho, V potential difference, current is I. If the length of the wire is doubling, area become A by 2. I think I made error here. This 2 goes here, this 2 goes here up. So it's 2 into 2 become 4. Okay, 4L. So 4L by A. A goes up. Right now I am correct. Yes. Great. So then you can separate this. You can separate this A by 2. This 2 goes here only, right? I took A, 2 is up. That's why. Okay, so look at this now. What this thing all focus? That option is there, not directly. Why I'm converting again? 1 by 4 into VA by rho L is there, no option. So that is the new current. 1 by 4 into VA by rho L. VA by 4 rho L. Understood this? When length is L, area is there, resistivity is rho, V and I. So you can find I is equal to V by R. Simple equation only. You guys try this, okay? I hope you got this. 1 by 4 VA by rho L. Got na? This information is clear, pakka? Okay. Hey, who is that? Rapid Fans Association created one. People are making like something like deviating from our side. Na? Brother, I am standing with the content. You don't create. I am not a celebrity. Okay, brothers and sisters, which you are following, which are actually watching this, I am not a celebrity. I am teaching physics. So give an importance, fans. You have to give that importance. Okay, I don't want to be such a fans. Okay, you have to be focused on the quality. I am not going with the celebrity like such a kind of things. Brother and sister, with a love. I am saying you have to concentrate here and focus on the examinations. Okay, yes, then only you remember me, instead of you are creating like unwanted something and all. That's a temporary entertainment, but leave from those things and come to the quality. Okay, only quality will exist in the market. Yeah, you got it now. You also be a quality persons. Okay, come on, let's move to the next questions. Come to the next question, brothers and sisters. Focus on the next questions. Yeah, two resistors are connected in a series. Look at this, two resistors are connected in series. Last moment, we want to motivate the students. The comment box, you want to discuss the things related to the questions and etc. the concept. Make sure you are very concentrating this one. If you are serious, I will make some fun. That fun only needed. If you make more fun, then we will move away from the physics. That's wrong. Okay, we have like some boundaries there. Within that boundary, we have to make fun. Otherwise, what happened? We cannot stand with the physics. Okay, come on, let's do this. Two resistors are connected in series across battery as shown in the figure. The voltmeter resistance, where the voltmeter is connected, voltmeter has a resistance, very important. That's why this question is a little twist. Okay, potential difference across 500 ohm resistor. If a voltmeter resistance is measured, voltmeter resistance 2000 ohm is used to measure potential difference across 500 ohm resistor. The reading of the voltmeter will be, look at this, okay, dhyan se dekho this question. Come on. So here, if you suppose you are connecting a resistor, it's not a resistor basically, voltmeter. So I'm drawing exact concept here. It's a voltmeter you attached here, but the voltmeter have a resistance. That's why I'm drawing like this. What's that voltmeter resistance? Look at this. What's the voltmeter resistance? 2000 ohm voltmeter resistance. Okay, so there is a voltmeters can't only mention, but voltmeter resistance. So that you want to consider now. Now focus on this. Okay. What is the reading of the voltmeter? Where the voltmeter is connecting? Voltmeter is connecting across the 500 ohm. So question is asking like what is the voltage across this 500 ohm, because voltmeter is connected there. How will you find that voltage across the 500 ohm? Sir, voltage across the 500 ohm will be current into resistance, Ohm's law. Voltage across the resistance, how will you find? We have many tricks are there. I will come back to that. For anyway, we want to find the potential difference. We require to find what? Current first. How can we find the current? Let's look. In order to find the current, total resistance circuit. What's the total resistance circuit? Can you say? Yeah, sir, this 500 and 2000 are connected in parallel, right? So when these two are parallel, you will get some value. Then that value and this value are in series connection, right? So you can add for the total. So first of all, I am doing in the descriptive format to you. Focus on this. This 500 and 2000, no, RP. Let me call RP means what? Resistance in parallel unit. What's the answer? That is, R1. You guys, I little bit take the basic way. When two resistance are in parallel, what's the formula? R1 into R2 plus R1 into R2 divided by R1 plus R2. Okay, when two resistance are parallel. In case anyone forgot, repeatedly read this. All right. What's R1 value? R1 value is 500. R2 value is how much? 2000 divided by 2000 plus 500. How much it will be? 2500. If if you cancel this 500 and 2500, how much it will be? 5, right? Am I correct? 2000 by 5 will be how much? 400, right? So 400. So this unit resistance is how much? 400. Then can you say what will be the total resistance? This parallel unit plus this one, because they are series. So it will be 400 plus 600. It will be what? 1000 ohm is the total resistance. Understood this? I told you, no, it can be asked like a part-wise question also. Okay, part-wise, separately it can ask. Okay, fine all. So what's the question? We have to find the current, right? We have to find the current. How will you find the current? According to Ohm's law, I is equal to V by R. I is equal to V by R. What's the V value here? 20, sir. What's the R value here? 1000. Okay, so this 0 get cancelled. 2 by 100 is how much? 2 by 100 is 1 by 50 ampere. You got the current? Okay, sometimes in a board examination and all, they will ask like A part, B part, C part, sub part. First part maybe determine the current. So you got a mark, 2 mark now. Okay, then go to the B part. What's the B part now? Here there is no B part. So we can find out what's asking here, the reading of voltmeter. What is the voltage across this one? I will tell you an idea, okay? We can do this one many ways. I told in my series of sessions, like, you have a multiple way to solve all physics questions. Here, let me use a simple way. One thing, what's the total voltage you given? It's a DC circuit, right? 20. So here, I can find the voltage very quickly. How, sir? Sir, what's the current here? Current is going, look at this current. Some current is coming from the battery. As it reaches here, it's split because here it is a 500 and 200. Okay, then what happened? The current will be recombined again and flows through over 500. So what's the current flowing through this 600? That's again equal to total current. So what's the current through here? Yeah, I can find voltage across this one very easily. Okay, what's the voltage across this one? So I into R. So what's the current here? Current is the total current. Here current is what? Total current. How much it is that? 1 by 50. What's the resistance of this one? 600. If you solve this, you will get how much? Tell me. 60 by 5 will be, that is 12 volt, right? What is that? Voltage across this one. So what's the voltage across this unit then? So the total is 20. Voltage across here it is 12. Then what's the remaining? 8, right? So what's the voltage across this one then? 8 volt. Understood? What's the voltage across this one? 8 volt, because 12 is like here. 12 is like here, then 12 volt is here. What's the remaining volt? What's the remaining volt? It is, 8 volt is the answer. 8 volt is the answer. Look at this. 12 volt is also option is there, but 12 volt is voltage across here. So from the total 20, 12 volt potential drop across takes place here, then remaining will be here. So answer is 8 volt. Answer is 8 volt. You got it now? You got it right? Oh, yes. Rafi sir, fans also, student also studying now. Great. Salute, Merabai. Right now you are my real fans. Okay, yes. So this is the final answer. You got na, brother, you got na, you got it right. Great then, great. Okay, yes. Quality time, na, quality time. This is a very important time. Concentrate on the studies. Okay, last moments, you guys are taking effort, we teachers also taking effort. Our together efforts makes, you will get a good result. All right? Yes, then you will remember us for a lifelong, and we remember you guys also for lifelong if you make such a quality relations from mind to mind. I am not seeing you, but I am only talking you, but I am teaching you like, as very deeply from mind to mind contact. Okay, come on guys, let's focus on the next questions. Let's break the next question. Very beautiful question. Okay, one of the beautiful expected pattern. Come on guys, hopefully you are getting, enjoy the sessions. Let me wind up the session very quickly. Okay, your coffee is cold, na? Coffee is cold. There's a question is there in the 11th standard. I let me check how many of you are remembering that question. I might discuss this also in the normal sessions. That question related to the coffee, you remember? Yeah. While you are waiting in a restaurant, will you wait the friend by adding sugar in a coffee or without adding sugar in a coffee? How do you wait the student? How do you wait your friend? Like by adding sugar on the coffee or without adding sugar on the coffee? So the answer at that time, many students said to me like unwanted discussion everywhere done in the class itself. Sir, my friend is a diabetic, so I will wait him without adding sugar. Such a comment and all. The moment where I am discussing this question, I am getting that's unwanted. Okay, that fun are allowed. That fun are allowed. Oh, such a kids also there. No, that's entertaining. They will survive in their life. Okay, so I am really enjoying that moment. That comments, that kind of comments comes. Okay, but what's the real answer? You know, right? It is based on Newton's law of cooling. Anyway, leave it. I am talking about the coffee. Na? Where's your coffee? Coffee is in your study table is there, na? Then you can drink the coffee, maintain the energy level. Come back to this question. Yeah, come back to this question. Yes. Shakibul Hassan, Mare Pakistan boy. Come on, let's focus on this question. Current measured. Come on, next question. It's what this one? Wheatstone bridge, right? Wheatstone bridge basic level question we had done. Now let's focus on the next question. A current measured by an ammeter. What is ammeter? Here na, dekho, ammeter is there. What is the current is measured? It's an MCQ, but this can be asked like a 3-mark questions, everyone. Okay, so dhyan se dekho. Come on, current measured by the ammeter A in the reported circuit when no current flows through the 10 ohm resistor. 10 ohm resistor kaha hai? Kidhar hai? 10 ohm resistor na sender branch. What's that? A sender resistance, no current is flowing. It's a Wheatstone bridge, sir. When there is no current is flowing through the center line, then that Wheatstone bridge is called what? Balanced Wheatstone network, right? Oh, balanced Wheatstone network. So no current is flowing means what? That part is not offering any resistance to the circuit. Because only the place where current passing area only will consider for the resistance. So it is a useless part. Okay, you have some friend like useless, right? So here it is such a friend. Okay, so no current is running. So whenever no current is running, they are saying through any resistance, you can throw them out. That's a useless, unwanted. So when you throw them out, come on, let's guys, throw them out. What you will get? Let me redraw then. Oh, then whenever you are removing the useless part, the things become quality, right? Like in a tomato box, one tomato is bad, then what happened? What that shop wala atmi do? Yeah, they will remove that tomato out, right? The remaining all tomato will be glow more than. Okay, so similarly, it's a useless part, just avoid, just avoid. Are you getting, So this all I am saying to keep your mind the concept. The all fun, or if it comes in my language, then see, it is for making the concept stick in your mind. Okay, so I have lot of things, the comment from the students getting, they never forget even after the 12th or something, like they're still remembering something I taught like in the fun way. Okay, so that's why I'm using that, I'm entertaining that, I'm enjoying. Hopefully you also getting that. Come on, this is 3 ohm resistor, here it is 6 ohm resistor. All right, useless, remove it. Where's useless here? No current. Hey Saleh, jaya out. Okay, go outside. Yes. Such a way you should throw them out. Then here it is the ammeter. Here it is what? The 36 volt battery. All right. Yes, sir. Fine. So our aim is what kind of current? How much current? You know, to find the current, voltage is ready. You should find the total resistance. Easy, right? Okay, before it, let me tell you one more thing to you. Is it a balanced Wheatstone bridge, right? How do you identify that? No current is running. When it's a balanced Wheatstone bridge, you know that P by Q is equal to R by S. Balanced condition. P by Q is equal to R by S. That is, children, sometimes you might learn R1 by R2 is equal to R3 by R4. Anywhere, if you learn, no matter, you don't want to follow this equation. Whatever the equation you learn, that's enough. But the concept is this much only. The left top by right top resistance is equal to left bottom resistance by right bottom resistance are equal. Then we will call it as it's a balanced Wheatstone bridge. So what's the left top here? P place. This is a P place. How much it is? R, sir. What is the right top? That is 4, sir. What is here? 3. Here it is 6. When you solve this, you can find what? R. Okay, how much you will get? This become 2 and 2 get cancelled. You will get R is equal to 2 ohm, right? R is equal to 2 ohm. Hopefully you got that. So now I can replace this R by how much? Tell me. This R by 2 ohm. R by 2 ohm. Now I hope hopefully you are doing this. So these 2 and 4, how these are connected? Tell me how these are connected. Series, right? They are series in line. What about this one? Tell me this one. This one also series. So 2 and 4 are in series. Then how will you find the total? 2 plus R. Tell me then how much it will be? 6 ohm, sir. What's the total of this unit? This unit, tell me, it's a 9, right? 3 plus 6. 3 plus 6. So 3 plus 6 is how much? 9 ohm. Then you can replace one. This is 6 ohm here, 9 ohm here. How they are? How they are? They are parallel each other. They are parallel each other. When two resistance are parallel each other, how will you find the total? Yeah, product of resistance divided by sum of the resistance, right? You can solve this. 3 and 5, then it's 18 by 5. Are you getting this? Are you getting this? You are waiting me? Oh, you're waiting me? You are done? Oh, great then. Great. So total resistance is 18 by 5. So you can find I then. Come on, how to find I? Why we are finding I? Because ammeter want to measure, ammeter reading. So I will you find V by R. What's the V value here? 36. What's R value you got? 18 by 5. 5 goes up, 36 and 18 get cancelled. You will get what? 10 ampere. Hopefully you guys got this. So 10 ampere is the right option. 10 ampere is the right option. Okay, we start with some good level question this one. So here it's like a 3-mark expectable pattern. Even it is here present like an MCQ. What are the questions? What are the point? What are the things you learned here? Yeah, whenever no current is running through the central line of the Wheatstone bridge, it is like a balanced Wheatstone bridge. When it's a balanced Wheatstone bridge, then you can remove that. The central portion, it's a useless part, a bloody fellow. Throw them out. Then when you throw them out, you will get this kind of easy network. And again, tell me this again. It's a balanced, right? What's the balanced condition? P by Q is equal to R by S. This by this equal to this by this. So you will get what? R is equal to ohm. Once you got R is equal to ohm, find out the total resistance. V is ready. I you can find. Got it now? Got it? Important. All right. Yes. Can I go to the next question? Pakka clear to you? Clear. Can I go to the next question? Yes, sir. Fine. Okay, Kalyan Ale Muhammad AK 47. Come on, let's do the next questions. So how can I avoid this discussion of current electricity without doing a KVL question? That you are wondering, right? Then here it is the KVL question to you. KVL is the one of the guaranteed question from current electricity. KCL and KVL you cannot avoid. Here it is sample question to you. Come on, let's break this question also. You guys can also try, okay? You guys can also try this one. Then later if you are not getting the solution, you can again use the video and go back. The video again will be posted in the saved here in the YouTube live itself. Any question you have a felt doubt, you can go back and check it, okay? Yes, come on. The value of current in the, so everybody please draw this circuit diagram into your paper. This circuit diagram. Yes, it's a KVL, okay? It's a very important pattern. Hopefully you all tried this one. Anyway, you can see, you can solve this pattern question also. What cell here? Let me drawing for you. I can use here now. I can work on this question itself, right? You guys will copy the another diagram, right? So then come on, and let's do this. For doing the KVL, if it is given like it is like nothing is marked over here, first step will be you should mark the vertex properly. Okay, vertex properly, because we need to call some loop name, right? So we can call what? A here, B there, C here, D here, E here, F. Okay, A, B, C, D, A, B, C, D. Anybody can dance. Come on, A, B, C, D, E, F. That's we called the loop. Now you can do one more thing. What else is left here? Current direction is not marked, so you can mark the current. Oh, here it is. You guys get confused. Sir, there are two cells are here. Then how can I mark? Where from I started marking? This is a question really every time I'm getting from the students. So see children, whenever multiple cells are present, one thing is no matter whatever the direction you marked in KCL, KVL questions, if you do it your own conventional way, then you will get what? Current is negative or positive. If it is getting negative means what? Negative means that you assume the direction of current is opposite to the actual current. KVL solution will direct you to correct. Okay, that freedom is there. But you can do one more thing. Okay, to avoid that negative, if negative comes, don't worry, you should write last. Assumed current direction will be opposite of actual current. That information you give, you will get full mark. In case if many students, to avoid that negative current and all, don't worry, you don't want to concentrate on that all. In case if you feel so, I will tell you a small trick, sometimes this may work. You have to mark the current direction when multiple cells are present. You have to give the priority to the higher voltage cell. Okay, what's higher voltage cell? 140 and 90. 140 is the higher one. So you can mark the direction of current from the higher voltage cell. So higher voltage cell positive is here. So let's mark the current direction from here. So this is what we call I current. Okay, I. When I comes at this junction, what happen? I will split, right? I will split. Let me say I1 goes through 6 ohm. What's remaining then? What's remaining then? I minus I1 goes through 5 ohm. Did you mark that? Properly mark, all of you. Okay, properly mark. Someone got the answer now. Great kids. Please draw this one. Yeah, but I want to teach you all. So brother, I am just maybe lag for you because I am teaching to the all other kids who are watching this. Okay, you can relax. So we marked all current, right? Now how many unknowns are here? I am just teaching you only one type of question, one question only, but this question content, you need to able to solve all this kind of questions. You want to avoid the fear of approaching all KVL questions. Okay, that's what my plan. So dear all, focus again. How many unknowns are here? There are 2 unknowns, right? What are the unknown values here, sir? We don't know I, and we don't know the I1 also. So 2 unknowns are there. Whenever 2 unknowns present, mathematically to solve 2 equations is required. How many equations required for 2 unknowns? 2. When 3 unknowns, 3 equations, like that. So here 2 equation is needed. First you should analyze this. So okay, so very carefully you should watch this one. 2 unknowns are there. So 2 equation is required. To make 2 equations, we require to consider 2 loops. How many loops are here? 3 loops are here. Did you see that? There is a 1 loop here, 1 loop here, and 1 bigger loop. There are 3 loops. Once again, this one, and overall it's another loop. There are 3 loops, but we don't want 3 loops. We only need 2 loops. Why? Because we only need 2 equations. Okay, because 2 unknowns only present circuit. If 3 is there, then 3 equation. Okay, 3 equation, 3 loop. So here this time only 2 loop. Let's do that. Let's do it. So let me consider the loop number 1. What's loop number 1? If you take the loop like me, then you guys can cross verify. A to B, B to C, then F, then A. I am taking this loop, okay? A, B, C, F. This way I am planning to walk. A to B, B to C, C to F, F to A. Alright, apply KVL. What's a KVL? KVL, how will you apply? Sigma of E, you should give for the board examination this equation first. Sigma E plus sigma IR is equal to 0. Algebraic sum of the EMF in a loop plus algebraic sum of voltage drop across the resistance is come to be 0. Come on, in this loop, you have to give this, okay? Yeah. Where from we are starting? Starting is determined where you marked the point. A, na? So you are going from A to B. When you go from A to B, what you are seeing? You are seeing negative to positive. Negative to positive of a battery, if you travel, EMF is taken as positive, right? So plus 140. When you go from negative to positive, EMF is positive. Okay, 140. Then how you are walking? What you are seeing the next arm? BC, A to B done. Then B to C walking. B to C you are walking along the current, right? You are going B to C. The current also in same directions. Then IR will be negative. What's I value here? I into what's R value here? R value is 200. Then where you reach now? C. Then how you are going? C to F. C to F. C to F. How you are walking? Along the current again. C to F, na? Current also down. So minus IR again. Voltage of minus IR. Minus, what's the current here? I1. What's R here? 6. So minus 6 I1. Understood? Then F to A, nothing is present. Then you want to F to A, you completed the loop, right? So you can write is equal to 0. You got one equation, right? Or rearrange this one. You can rearrange this one. If you all negative term bring to that side, it become positive, right? Come on. Minus 200i minus 200i minus 200i. If you bring 6 minus 6i1 to there, it become plus 6i1, which comes to be how much it will be? 140. You got one equation. Can we simplify this a little more? In case you are getting this kind of any simplification will be there, you can simplify and make its very simplest form. So if I think we can divide with the 2, right? When we divide, so is it it's 20, right? Sorry, it's 20. Oh, Oh, you guys may be commenting, no? So this is like 20, it's a 20, okay? Here it is 20. I wrote it wrong actually, 20. So therefore here it will be 20i, okay? Yes, all. Okay, great. 20i. So we can divide the entire things with the 2, right? When we divide all term with the 2, what we will get is a dividing, okay? Dividing the above all terms with the 2. So it's become 10i plus 3i1, which is equal to 7d. Let's call that is equation number 1. I'm correct, right? Okay, I'm correct, right? Yes. So then look at the next loop. Let's take the next loop. Take the next loop, everyone. Yeah, which loop we'll take? We can take, F, C, D, E, F, C. This way, F, okay? Yeah, I'm taking this way. F to C, then C to D, D to E, E to F. Apply KVL again. How you are working? F to C first. F to C you are going. Current is down. You are going opposite to the current. Opposite the current, IR is positive. So, walking opposite to the current, IR is positive. So, IR is what? I1 into 6. 6I1. Okay, positive. Then how you are walking? C to D, right? C to D. Along the current, IR negative. Minus 5 times I minus I1. What's the current there? I minus I1. Then how you are walking? D to E, right? D to E. What's D to E present? Positive to negative. EMF is negative. EMF is negative. 90. Then how you are walking? E to F. Nothing is there. So it's equal to 0. It's equal to 0. Open the bracket. Solve this. 6I1 minus 5I. Minus 5 and minus I1 become what? Plus I1 plus 5I1 which is equal to what? 90, right? Minus 90 you can bring to that side. Plus 90. We can simplify this. 5I1 and 6I1 comes to be how much? 11I1 minus 5I, which is equal to 90. Okay, you got second equations. Now focus on this equation and this equation. How can we simplify that? Yeah, sir. Look at the coefficients. Okay, look at the coefficients here. Here 10i. What's the coefficient of i here? 5. Can I make 10? Yes, sir. You got the idea? Multiply 2, right? Multiply 2. When you multiply this complete equation by 2, then it becomes 10i here. Just multiply 2 on both sides. What you will get? 11i into 2 means what? 22i1. Are you seeing that? Okay, let me do the above thing. You just multiply 2 for this all term. What you will get then? Let me do that. Okay, let me write here. 22 I1, let me write below of this I1. How much I1 will get? 22 I1. If I multiply minus 5I with 2, I will get minus 10I. Okay, minus 10I. Then what is if I multiply 90 with 2, 180. What I done? I multiplying this equation with 2. Okay, this equation with 2. Hopefully you got that idea. So that's my equation number 2. Then how can I find this? How can I eliminate this one? 10i and minus 10i is here. Just add on these two equations, right? When you add this, get cancel. 3i1 plus 22i1, 25i1. When you add this, how much you will get? 250. So I1 will be how much? 10 ampere. What's the question asking here? Find the value of current in 6 ohm. Current in 6 ohm is what? I1, right? Current in 6 ohm is I1. So we got I1 is how much? 10 ampere, and 10 ampere is the option. Okay, 10 ampere is the correct answer. You got this? It's clear? It's clear to you? Very, very important questions. Hopefully you all got this one. Yeah, the session got overall. So I hope that you got a great information from Canada City. So thank you guys staying here for the stays here. Okay, so all of you have a good night. Then we can see in tomorrow's session with another chapter. Hopefully you all enjoy the sessions. Please practice this all. So do maximum questions again. Okay, so thank you all. We can see all the best. Next class we can see. Okay, bye all. Thank you.